my day in this class. Today we are going to discuss about the service and absolute ceiling of the aircraft. The steady level flight, the rate of climb defines whether it is flying about the absolute ceiling or the service ceiling. It means that if the rate of climb value, maximum value should be 0, that level is called as absolute ceiling. Whereas the rate of climb max is equal to 100 feet by second means that is service ceiling. So the both absolute ceiling and service ceiling represents the aircraft in a graphical format, and this is the absolute ceiling. And this area we say as service ceiling. So at this condition, the rate of climb max will be 100. The maximum value is 100 feet per minute. So based on this, we can say what is the time climb. That is, from the rate of climb, the time to climb is defined as the rate of change of altitude with respect to the time. So that is time to climb is rate of climb is equal to dh by dt. From this dt, time to climb will be dh by rc. It means from one altitude to another altitude, the amount of time taken to the climb. So that is T1 to T2 altitude is equal to dt. That is h1 to h2 dh by rc max. So the time to climb is the rate of change of altitude with respect to the rate of change of time, the rate of time, and the time is equal to the amount of altitude time during the rate of climb. So from the time 0 to the attained time is equal to altitude 1 to altitude h1 to h2, that is dh by rc. So at sea level condition, this h1 gets 0. So at sea level condition, h1 will become 0. So time will be t equal to 0 to h2 dh by rate of climb. This is the rate of climb that is excess power by thrust. So we are getting RC with respect to time is equal to when the time is minimum, the rate of climb should be maximum. So that is the time to climb. As we can represent in terms of graphical format, we can represent as from the rate of climb to the altitude. So this curve under is the rate of climb curve. Under this curve, the area represents the time to climb. Right? At any location from h1 to the sea level, this is 0 to h2. And under this curve, rate of time curve, this represents the time to climb. Right? After the time to climb, so we need to find out what is the gliding rate, and the power is off condition is engine failure condition. So already it is getting taken off. I mean, rate of climb is done, time to climb is done, and that is the service ceiling, other ceiling has achieved. Once this level condition, maybe it will get failure or any other issue, so the aircraft must be able to glide. So that condition we have to calculate what is the gliding velocity of the aircraft. Let us say the aircraft is gliding due to the engine failure from an altitude with some angle, right? So this is a power off condition, that is unpowered condition. So that time, so we have the lift, definitely we have the drag, and we have the some amount of weight. So from this is the altitude, and this is the distance to attain the touchdown point. So we need to resolve this as L equal to W cos theta, and drag will be W sin theta. Right? So by getting the L by D ratio, that is W by W, then W cos theta by sin theta. We are getting cos theta by sin theta that is L by D, or we call it as sin theta by cos theta, we can call it as that is 1 by L by D is equal to tan theta. Right? Then tan theta equal to 1 by L by D max. And it is the theta is minimum for landing. This is one of the theta. This is the angle theta. When the theta should be minimum means the L by D ratio should be maximum. So when the theta is very small, compared to very small, the landing will take place a large distance. Right? Now from this L equal to W cos theta, we can find out what is the unbound condition, what is the velocity of the particular airplane. So we can write this is equal to half rho v square s CL equal to W cos theta. This is velocity equal to velocity square. We are getting 2W cos theta divided by rho s CL. So if we do this square, we are getting V is equal to 2W cos theta by rho s CL. This is the velocity of this particular airplane getting, that is gliding from the unpowered condition to the land. So these are also considered the service ceiling, absolute ceiling time, and also we study about the rate of climb as well the time to climb. And next we are concentrating on the engine failure. What will be the velocity of the airplane and what will be the minimum L by D ratio and maximum L by D ratio selected. That is